We all know what an exponent means. We all know that an exponent means that you are supposed to expand this. You're supposed to multiply it times itself however many times. So in this case, if I have all of this to the third power, I would be asked to do this 3 different times. So 5m to the second, n to the negative second, multiplied by itself 3 different times. And if I wrote it out like this, it would be the exact same type of problem as what we were doing yesterday, just multiplying. So I would multiply 5 times 5 is 25, times another 5 is 125. I would add my exponents on the common variables, so m to the second, so 2 plus 2 plus 2 makes m to the sixth. I would do the n's, negative 2 plus negative 2 plus negative 2 give me n to the negative sixth. And because it's negative, I would move it to the bottom. So I'd have 125 m to the sixth all over n to the sixth. And that would be a correct final answer. So that is one option for how you can do these problems. There is a problem with this, though. This exponent was very small. Doing something to the third power is not difficult for us to write this out. You can write something 3 times. It doesn't take very long. But what if this exponent was a 10? Would you really want to write 5m to the second, n to the negative second 10 different times just to write out what it's going to be and then add all 10 of each thing? No. So instead, we're going to do, as was also suggested, we're going to just distribute the exponent. So this should be something that we're very used to. We see parentheses and we see a number attached to these parentheses. This isn't technically how distributive property works, but it works in an extremely similar way. So with this exponent, we're basically distributing exponents. Now we have done that before, but when we did it before, there were no exponents already there. So the question became, should I multiply them? Should I add them? Should I do something else with them? And we are definitely going to multiply them. And you can see that just by looking at what we got when we wrote it out. 5 to the third power, 5 times 5 times 5 is 125. So we got 5 to the third power. M to the second to the third, we ended up with m to the sixth. We had multiplied them. 2 times negative 3 gave me n to the negative 6. It's the exact same thing we were getting the other way, except instead of writing it out, we see that this exponent is going to go to each thing. In fact, when we did this before, and we didn't have exponents inside the parentheses to begin with, we did actually have exponents inside to begin with. When no exponent is there, what exponent is it actually?
1.
It's a 1. And if you multiply something by 1, it doesn't change. So when I brought the 3 in for the 5, I was doing 3 times the invisible 1 that's there. So we are always going to be multiplying when we distribute these exponents in, either to the invisible 1 that should be there, or to the existing exponents that we can see. Either way, we're going to end up with the same final answer. 5 to the third power is 125. M to the sixth will stay on top. It's a positive exponent. N to the negative sixth will move to the bottom because it was a negative exponent. So it works the exact same way.